Hello class, this is a video tutorial on the second set of examples of converting fractions into decimals. In these set of examples, you're going to see a particular type of fraction called recurring fractions. So let's take a look at this one. So here we go. The method is still the same. The denominator is our divisor, and 4, the numerator, is our dividend. So 9 into 4 we can't do, so we borrow another 0. And just to make this a little easier, let's write up our 9 times tables to the side here. So 9, 18, 27, 36, 36, 45, 54. Let's stop here for now and see how we go. So 9 into 40, the closest we can get is this 4 times tables, 9 times 4. So it'll be 9 times 4. That gives us 36 with a remainder of 4. We borrow the 0, and once again, 9 goes into 40 4 times. So it's going to be 4 with a remainder 4. And as you can see, we can already see a problem here because this division is going to repeat indefinitely, because 9 into 40 is once again 4 with a remainder of 4, and this will repeat forever and ever. So for this, we can write this as 0.444 dot dot dot, and this repeats forever. But with recurring decimals, we actually write this as 0.4 with a dot on top of the digit that is repeating. So 0.4 with a dot on top of it means that this 4 repeats forever. Okay, so let's keep moving forward with this next example here. Same deal. 3 into 2. We can't do that, so 0 point. And once again, 3 into 20. So let's do our 3 times tables. 3, 6, 9, 12, 15, 18. Now I stop here because the next one is going to be 21. So 18 is the closest we can get to 20, and that is 1, 2, 3, 4, 5, 6. So 3 into 20 happens 6 times with a remainder of 2. And as you can see, it repeats once again, because 3 into 20 is once again 6 with a remainder of 2. And as you can see, it's the same problem as before. So since this digit, or this decimal of 6, repeats forever, we simply write this as 0.6 with a dot on top, indicating that this 6 is recurring infinitely. Okay, so let's move to the next example. Once again, same method. 6 into 5. We know we can't do that, so we remove 0 points. And once again, we do our 6 times tables for this one. So 6 times tables. 6, 12, 18, 24, 30, 36, 42, and 48. The next one's going to be 54, which exceeds 50, so we stop at 48. Now I know that this is going to be 6 times 8 with a remainder of 2. Okay, so now 6 into 20, the closest one here is 18, which is the 3 times tables, 1, 2, 3. So 6 into 20 is 3 with a remainder of 2. And now notice that the problem is recurring again, in that it's repeating at this point. So if we do this again, 6 into 20 The closest one again is 18, so 3, remainder 2. And as you can see, the repetition of that 3 is going to happen forever. So this can be written as 0.8, but this time only the 3 is repeating. So we put the dot only on the 3. Okay, so that's the next example here. Let's do one more. This one's perhaps the hardest one, but it still remains as the same method. So 11 into 3, which once again we know we can't do, so we're going to start straight away, 0 points. And let's write up our 11 times tables. 11, 22, 33, and 44. So 11 into 30 this time. So 11 into 30 can't be 33, so we do 22. So that is 2 with a remainder of 8. Okay, so now we go into 80. If we keep going, this becomes 55, 66, 77. The next one will be 88, so we don't go to 88. So this is going to be 7. Okay, so 11 into 80, the closest we have is 7 times tables. So it's going to be 7 with a remainder of 3. And now look, 11 into 30, the closest one is 2 with a remainder of 8. And now notice how the repetition is now starting. 11 into 80, the closest one is 7 with a remainder of 2, and notice how that pattern of division will repeat forever. So since the 2 and the 7 are repeating, watch carefully how we write this as a recurring decimal. This would be 0.27, and we draw a dot on the 2 and the 7 because both these digits will repeat again. So 0.27 will become 27, 27, and that happens infinitely. All right, so hope that gave you an insight into converting fractions into decimals with repeating decimals or recurring decimals. Hope to see you then, and best of luck.